Good day. As you can see, we're looking at energy resources notes. So have that sheet in front of you, a few things to fill in. Now we're trying to look at energy on a grander scale rather than individual. What forms of energy do we need in our daily lives? How is it generated? And in some cases, what are the good things and the bad things about it? Well, we know the sun is essential for life on Earth. It's essential for plants. Plants can then make food. The energy can then move up through a food web. So biologically, it's very important. But we also use and produce energy on a large scale for things like heating and transportation and electricity. So we have an energy grid. In that grid, we may have electricity being generated. In this case, in BC, it's often by BC Hydro. We have natural gas that's shipped around the province, and we can use that for many things, whether it's a gas stove or for a furnace and these kind of things. We also need energy on a large scale for transportation. Some sources of energy are renewable, while others are non-renewable, so we need some definitions. Non-renewable means it cannot be replaced in our lifetime, so typically we'd say about 75 years. So a couple of examples are fossil fuels, where we have these carbon-rich materials that have taken hundreds of thousands or more years to form, like coal and oil. Then we have things like nuclear power. So we have these materials that we can use to get that. So it talks briefly here about fossil fuels. We know that we're mining these materials. You may see the coal trains going through Hope on their way out to the Delta port before they're shipped to places like Japan and China, where they can use that coal as a source of energy for manufacturing. We know when we burn fossil fuels, we make carbon dioxide. That's a greenhouse gas, and it's part of the carbon cycle that you should have learned about last year. Nuclear power. Well, BC is blessed with mountains and lakes and rain and snow, and these things can be used to make electricity. But in other places, they may be drier, they may not have mountains. They have to come up with other ways of making energy. So they might burn fossil fuels to make electricity, or they may use nuclear power. So along the eastern seaboard of the States and over in Europe and other places, nuclear power is quite common. Renewable means, hey, the source can be replaced in our lifetime within 75 years. It also does say if it's so vast it won't run out. So in BC, we're blessed with hydroelectricity. Hydro refers to water, the flowing water, and then we have a generator making electricity. Well, solar power, certainly in our lifetime, we expect the sun to keep rolling, roughly 5 billion more years before it decides to shut down. So we're good to go for quite some time. And we can use solar power to heat water, and that could be used for heating a home. And it can also be used to make electricity. And that electricity typically would be produced at a certain time and stored in batteries for later use. We also have wind power. There are all kinds of wind farms. Alberta and BC on the coast, there are some wind farms, certainly over in Europe. Where you're looking at North Sea in that area, they have wind farms as well, and other locations. We're going to watch a video about tidal power somewhere in Canada. You might know where there's some great tides. And biomass energy. Bio means living things, so we're using materials from living things, plants and animals. And often that's burning the material to make electricity. In many places, corn is grown not just to be a food, but also to be used as a fuel. So you can actually make ethanol from the corn. And that would be an example of biomass. Geothermal. Well, geo means rock or earth, and so that means getting the heat from within the earth to heat buildings. And in fact, geothermal energy can be used to heat and to cool, depending on the time of year. And so you may know people who use that at this point. Landfill gas, you may see pipes coming out of landfills, and those will often generate methane. And where are we at? We're now on the next page. This is just a brief paragraph about the greenhouse effect. So if you've ever been in a greenhouse in the summer, you know it gets awfully hot. And what happens there is sunlight is able to penetrate through the glass windows, enter the greenhouse, but its wavelength changes so the energy cannot escape. And so you just simply, it's like dumping more and more energy in there or trapping that heat inside the greenhouse. Similarly, we have greenhouse gases such as carbon dioxide, there's its formula, and methane, there's its formula, CH4. They allow the energy to pass through, heat up the Earth's surface, and then the Earth's surface radiates the heat back out, and then these gases trap it. Now, it does say the Earth would be too cold without the greenhouse effect, but humans, by our use of fossil fuels, our dependency on it, we have dumped more carbon dioxide into the atmosphere. And in other words, we've accelerated the greenhouse effect. And this is leading to climate change and an overall warming of the planet. And that is creating certainly problems in terms of life on Earth, particularly for other animals and plants. So let's just look at our simple diagram here for the greenhouse effect. So what we're saying here is we have the atmosphere, the solar radiation comes and heats up the Earth's surface. It can get through the greenhouse gases, but when it tries to leave, it's at a different wavelength and it cannot escape. So more and more energy builds up. So those are your energy resources intro notes.